All right, 3, zeros of polynomials. All right, now in this section, we're going to find all of the zeros. And when I use the term finding the zeros, you're not finding zero himself, but you're finding the numbers that make the polynomial equal zero, okay? You're finding what zeros it out, okay? Now, I'm going to go ahead and let you know you're going to need some paper because this section can get kind of lengthy when you're trying to do synthetic division, okay? We're going to start small, and I'm going to work my way up into some examples that are going to show zeros or answers that are not real numbers, because your answers don't have to be whole numbers or fractions. They also can be imaginary or irrational. So let's look at our first example. F of x equals x to the third minus 2x squared minus 13x minus 10. Okay? Now, I don't give you a start. I don't say k equals a number. You have to develop a list of possible zeros. Okay? That's kind of my first thought process. I need my list, okay? It's kind of like a number bank. This is going to be the numbers that you pick from to try your synthetic division with, okay? So how do I make this list? Well, your list is made up of what we call P over Q, okay? P over Q. Now, what is P and what is Q? Well, P would be the factors of the last number, the constant number, okay? The last number, all the factors that make up 10. So we know that those numbers would be positive and negative 1, 2, 5, and 10. That's all the numbers that would divide into 10. That's what I mean by factors. Now, Q represents, I'm going to write it here because I didn't leave enough room, the factors of the first number, okay? Now, your first number is an understood 1, all right? So your Q right now on this example is nothing but positive and negative 1, all right? So if I'm making this list, I would put all of my P's, each one of these numbers, 1, 2, 5, and 10, positive and negative, on top of each one of my Q's. Well, in this instance, all I have is a 1 for the Q's, and for my P's, I have a very small list as well, 1, 2, 5, and 10. So technically, your list is nothing but positive, negative, 1, 2, 5, and 10. Now, I'm not trying to confuse you, but when I say list, these are the numbers that could possibly break down that polynomial. You wouldn't try 3. You wouldn't try negative 4. They're not in the list. The only numbers that could break this down would be positive and negative 1, 2, 5, and 10. Okay? So, picking a number to start off your synthetic division, let's pick 2. And again, you're going to look at that polynomial and make sure it's in descending order. 3, 2, 1, and 0. We're good. We're not missing a term. And you're going to list the coefficients out beside it. So we got 1, negative 2, negative 13, and negative 10. This is the method we did in 3.2. So if you use synthetic division, we got 2 times 1, which is 2. 2 minus 2 is 0. 0 times 2 is 0. 0 minus 13 is negative 13. And negative 13 times 2 is a negative 26. And negative 10 and negative 26 is a negative 36. So you can see by you having a remainder that 2 does not work. Okay? So technically, you can make a list so you'll know what numbers not to keep trying. 2 don't work. So we're going to erase. And you need to go back to your box and try another number. Now, to save time from erasing, it would be best that you take the numbers in the chart, plug them in for X. Where you see X, plug in and see if it's going to equal 0. If it does not, then that lets you know that number doesn't work. Now, if you plug in 2, you would have gotten negative 36 when you hit equals. That would have said, nah, that doesn't work. So that would save you on doing the erasing, all right? So that's what I would use to plug in picking what number to show the synthetic division on, okay? Because I will require to see this show work for your test, okay? So you're going to take, let's do negative 2. That's in my box. Now, like I said, save time. Plug it into the calculator and see what it gives you. And once you get one to work, then show me the synthetic division. So if we try negative 2, we got negative 2 times 1, which is negative 2. Minus 2 is negative 4. Negative 4 times negative 2 gives me a positive 8. Negative 13 plus 8 gives us negative 5. Negative 5 times negative 2 is 10. And 10 minus 10 is 0. So we see that our remainder is 0. So that means that negative 2 works. That's one of your 3 answers. So that means you need 2 more answers. Now, you can go back to the box and try synthetic again. But your goal is to get this to 2nd degree, meaning that's where you want to always stop your synthetic division. Now, if I was in 3rd degree, I know that this row is going to start with x squared, which means that's 2nd degree. I would stop there with the synthetic division, because when we get to the problems that are not real, meaning that the next answers are imaginary or irrational, then you're not going to be able to find the numbers in the box to break this down. You're going to have to do quadratic formula, square root method. You're going to have to use one of those methods that we talked about on test 1 for things that do not factor. So let's walk this down. Our new polynomial would be x squared minus 4x minus 5 equals 0. And we're going to factor it. That's how I could get my next 2 answers. Factor it. This is an easy factor. X and x, we are subtracting. To get my 4, only factor you got is 5 and 1. Make sure the 5 is negative. 1 is positive because you got a negative 4. So if you set each parenthesis to 0, you would get positive 5 and negative 1. So those are my other 2 answers. So we found out that the 3 numbers that would break this polynomial down, and I'm going to write them in curly Q. We know that negative 2 is an answer, negative 1 is an answer, and positive 5 is an answer. Those are the 3 numbers that would work. And this is what we're going to be doing on this section. We're trying to find the answers, and these are called zeros, because if I was to plug in a -2 where x, it's going to make it equal 0. If I was to plug in -1 where x, it would make it equal 0. If I was to plug in 5 where x, it would make it equal 0. So these are the only three numbers that will make this polynomial equal 0. Second example. F of x equals x to the third plus 5x squared plus 2x minus 8. So again, the very first thing I want to do is come up with my list. Okay, what numbers am I going to pick from? This is known as your possible list of zeros. Possible list of zeros. And again, that's made up of P over Q. P represents the factors of the last number, of the constant number. So we have positive and negative 1, 2, 4, and 8. Those are all the numbers that would divide into 8. Your Q represents the first number. And again, since this is example 2, my first number is just 1. Okay? So my list, if I take each one of these P's and put them on top of this Q, which is just 1, I'm only going to have my P's, which would be positive, negative, 1, 2, 4, and 8. That's all I have in my list. So again, you wouldn't try numbers like 10, 3, negative 15, because they're not in your list. Okay? So, what I would do at this time is take the number in the list and plug it in for x. That way you'll know if it's going to work or not. So you won't have to waste your time doing synthetic division if it doesn't work. Now, I do want to see the synthetic division of the answer that works. Okay? So, we can try 1. Check your polynomial. We go from 3, 2 to 1 to 0. So we're in descending order. We're not missing a term. And we're going to write those coefficients. 1, 5, 2, and negative 8. Bring down the 1. And we're going to multiply. 1 times 1 is 1. Plus 5 is 6. 6 times 1 is 6. 2 plus 6 is 8. 8 times 1 is 8. Minus 8 is 0. So again, we got a remainder of 0. So 1 works. Luckily on that first one it works. 1 works. So this was in third degree. So I found one answer to work. So this row would represent second degree. That's what it's going to start off with. So I wouldn't keep going with synthetic division. I'm going to stop and I'm going to factor. So this would represent x squared plus 6x plus 8 equals 0. And there you see your trinomial. I remember telling y'all factoring never goes away. We use it all the time. So we're going to factor. So I'm adding to get 6. So I got x and x, 4 and 2, both of them positive. So that would give us, if we set it to 0, x equals negative 4 and x equals negative 2. Those are my other two answers. Okay? Now, you might be wondering, okay, what if I would have played with -4 first? It would have worked in the synthetic division. Then your trinomial right here, it would divide into 1 and -2. It's going to produce the other two answers. So these three numbers are the only numbers that's going to work. So it doesn't matter. You could have played with -2 in the synthetic division. Then your polynomial would have given you 1 and -4 as answers. So these are your only three answers. So we know that -4, -2, and +1 are the three numbers that will zero out this polynomial. Okay. Next example, number 3. F of x equals 15x to the third plus 61x squared plus 2x minus 8. So very first thing you're going to do is we're going to generate our list. I need to know my list of possible p's over q's. Okay? Now this time you have a p of 8 and you have a q of 16. So I mean 15. So I've given you a number bigger than 1 for your q. So I want you to watch me as I generate this list, because you're going to be asked to give the list of possible zeros. That means the numbers that work, it wants to know the list. What numbers would you be picking from? So our p's would be positive, -1, 2, 4, and 8. And our q's would be positive, -1, 3, 5, and 15. Those are the numbers that would divide into 15. Those are your q's. And your p's are 1, 2, 4, and 8. Those are the numbers that would divide into 8. Now, it's called P over Q. That means each P number has to go on top of each Q number. Now, this can get lengthy. Now, I want your list to be in lowest terms, okay? So that means if you have fractions, they need to be reduced, all right? And don't repeat yourself. Make sure your list only has that number once, okay? So here we go. Now, I know that if I take each one of these p's and put them over the first q, which is 1, that's what I did on the first two examples. All I'm going to have is the whole. These are your whole numbers. Your back numbers, your p's represent your whole numbers. So I know I'm going to start my list with positive and negative 1, 2, 4, and 8. I also know that 1, 2, 4, and 8 are the tops, because that's P. Them your top numbers. So to me, it would make sense to just walk my Q down, if that makes sense to you. I'm going to now write each one of the P's, 1, 2, 4, and 8, on top of the next Q, which would be 3. So I'm going to have 1 over 3, 2 over 3, 4 over 3, and 8 over 3. Done with that Q. The next Q is 5. So that means my bottom needs to be 5. 1 over 5, 2 over 5, 4 over 5, and 8 over 5. And my next Q, my bottom is 15. So 1 over 15, 2 over 15, 4 over 15, and 8 over 15. Now, when I look at each fraction, they're all in lowest terms. And I knew that from the beginning because 15 and 8 have nothing in common. So I knew that my fractions would not reduce. So this is my list. This is what you're picking from. Now, each one of these numbers, if you notice, I put my plus or minus sign at the beginning. But it's on every number, okay? I wrote it here at the beginning, but it goes on every fraction, every number in there. It could be the positive of it or the negative of it. So, now I only need 3 numbers to work, okay? 3 numbers to work. And I don't want you to be afraid of fractions because a lot of your answers will be fractions, okay? But I'm going to show you how to do the synthetic with fractions. Let's try, well, let's just jump out there and try a fraction. Let's try 1/3. Now again, I'm going to go look at my polynomial. Third, second, first. So I'm good. I'm not missing a term. So we're going to have 15, 61, 2, and negative 8. Bring down the 15. Now, you can type this in the calculator. You're going to multiply 1/3 times 15. You can type that in your calculator. Now, what I'm doing mentally is I'm dividing by 3 because this is a fraction. So it's kind of doing the opposite of me multiplying. I'm dividing. But you can type that in your calculator. 1/3 times 15. 1 ABC 3 times 15 gives you 5. And you here I said the ABC button because that's your fraction button on your calculator. 1/3 times 15 is 5. Or you can say 3 divides into 15 5 times. And then you're going to add 61 plus 5 will give you 66. And then you're going to say 1/3 times 66. Or you can divide 66 by 3. And that would give us 22. So you say 22 plus 2. And that will give you 24. 1/3 times 24 or 24 divided by 3 would give you 8. And negative 8 plus 8 is 0. It works. 1/3 worked. Because I got 0 as a remainder. So 1/3 is one of your 3 answers. So to find our second 2 answers, keep in mind, if we started off in 3rd degree, this row starts 2nd degree. So we're good with the synthetic division. So we're going to write, this would be 15x squared plus 66x plus 24 equals 0. Now, I would divide off a 3. That's a common factor between 15, 66, and 24. That's a GCF. I would take the 3 off. And that would help me factor. Then I'm left with 5x squared plus 22x plus 8 equals 0. And we're going to factor. I'm going to do 5x and x in the front because that's all I got with 5. And with 8, you can use 1 and 8 or 2 and 4. I'm going to use 2 and 4, 4 and 2. And you know you need to check your outer, inner. 5 times 4 gives you that 20. 2 times 1 gives you 2. And that will add up and give us 22. And they're both positive. Okay? So if you set each parenthesis to 0, you would see that x would equal negative 2/5 and x equals negative 4. So these are my other two answers. Okay. So, kind of erase a little bit so I can write. My three answers for this polynomial will be negative 4, negative 2/5, and a positive 1/3. So I'm showing you, you see only one whole number worked. The other two answers are fractions. And that's okay. Okay? Okay, let's look at the next one. Example 4. F of x equals 6x to the third plus 17x squared minus 31x minus 12. So we're going to create our list of possible zeros, and that's represented as P over Q. So again, P represent your last number, the factors. Q will represent the first number's factors. Now, 6 and 12 got a lot of factors in common. They got a lot of numbers in common. So you're going to have fractions that are going to reduce, okay? So let's list our P's. Our P's would be positive negative 1, 2, 3, 4, 6, and 12. Our Q's would be positive negative 1, 2, 3, and 6. Now we're going to place each P on top of each Q. And I just normally walk my Q's down. I list my P's first because those are your whole numbers. So I would list positive negative 1, 2, 3, 4, 6, and 12. Now that would be if you had 1 on the bottom as a Q. Now put 2 on the bottom. If you put 2 on the bottom, then you can write 1/2, but I don't need to write 2 over 2. Do you see that reduces to 1? So I'm going to erase it. I don't need 2 over 2. I can do 3 over 2, but I don't need to write 4 over 2 because 4 over 2 reduces to 2. 6 over 2 reduces to 3, and 12 over 2 reduces to 6. So with 2 on the bottom, you really only need 1/2 and 3/2. Move to 3 on the bottom. You can do 1/3 2/3. Now, I don't need to write 3/3. That reduces to 1. You can write 4/3. 6/3 reduces to 2. And 12/3 reduces to 4. Last Q is 6. So I can do 1/6, but 2/6 reduces, 3/6 reduces, 4/6 reduces, 6/6, and 12/6. So all I can do for row 6 is do 1/6. So that would be my list of possible zeros. Okay? That's in lowest terms. I don't write the ones that can be reduced. Keep that in mind. Now, we're going to do synthetic division. And I'm going to check. I go from third degree, second, first to no degree. So I'm not missing a term. I got 6, 17, -31, and a -12. Bring down 6. And you can pick. I would at this point take the numbers in the list. Just pick a number and plug it in for X and see if it's going to work. I would stay away from big numbers like 6 and 12. I would stay more either towards the front or the middle. Your whole numbers that are that big normally don't work unless you have a small list, unless you have a really small list. Let's try 3/2. Want to show you a synthetic with a fraction that doesn't have 1 on the top. 3/2. Now, on the previous problem, we, I think, did 1/3, and I told you I was dividing by 3. Well, I'm going to divide by 2, but I'm going to have to multiply by 3 before I write my answer. And this is me doing it without a calculator. But you can type in 3/2 times 6, and it will give you your answer. Okay, so just type it in. Don't struggle with the fraction deal. You can use your calculator. So we're going to say 6 divided by the 2 gives us 3. Times 3 is 9. So 3 ABC 2 times 6 will give you 9. And then you're going to say 9 plus 17 will give us 26. 26 divided by 2, which is 13, times 3 is 39. And so 39 minus 31 will give us positive 8. 8 divided by 2 times 3 will give us positive 12, which is 0. And again, that remainder is 0, so it works. So, you do know this will represent second degree because we started in third degree. So this would be 6x squared plus 26x plus 8 equals 0. Now looking at 6, 26, and 8, they all have a common factor of 2. Divide it off. That will leave us with 3x squared plus 13x plus 4 equals 0. And we're going to factor. So in the front, I got 3x and x. In the back with 4, I'm going to use 4 and 1 because 3 times 4 is 12. 1 times x is 1. Add that together. That would give me my 13. And they're both positive. So we set them to 0. And you would get that x equals negative 1/3 and x equals negative 4. So these are our three answers. 3/2, negative 1/3, and a negative 4. Okay. Example 5. F of x equals 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2. Okay. So we're going to make that list. You see I'm doing the same process on each problem. I need my list of P over Q. Possible zeros. So my P would represent the factors of my last number, which would just be positive, negative, 1, and 2. My Q would represent the factors of the first number, which would be 6. And that would just be positive, negative, 1, 2, 3, and 6. So when I do my list, my top numbers, my whole numbers, are only positive, negative, 1, and 2. Those are the only P's I got. That's the only tops you should have. And so I'm going to put 1 and 2 over each Q. So I've already done 1. That represents, that first row represents 1 on the bottom. So now put 2 on the bottom. And so I would have 1 over 2 and 2 over 2. But do you need 2 over 2? No, because that reduces to 1. Next bottom is going to be 3 on the bottom. And I can do 1 over 3 and 2 over 3. Last bottom is 6. I can do 1 over 6, but 2 over 6, that reduces to 1/3, and you already have it, so I'm going to erase it. And that's my list. That's what I'm picking from. So like I said, I would take these numbers and you can plug them in for x. Right there. Plug it in for x and see which one will give you a 0. Okay? Now, this time I have increased my polynomial to 4 degree. So that means there's 4 numbers that work. The first 4 examples, we were only looking for 3 answers to work. This one will have 4. So your lead exponent lets you know how many answers is in this particular polynomial. Okay? So, let's try. Let me write my coefficients. I'm not missing a term. 4, 3, 2, 1, and 0. So I'm going to write 6, 7, negative 12, negative 3, and positive 2. Bring down 6. And out of our list, let's try 1. 1 times 6 is 6. 7 plus 6 will give us 13. 13 times 1 is 13. Negative 12 plus 13 is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Times 1 is negative 2, which is 0. So it's zeroed out. So that lets us know that 1 is an answer. Now, I wanted to show you how I would continue with my synthetic division. I would not start back over at the beginning. I would start right here. Draw a new house and drop down that 6. And the reason is you're trying to get this thing to second degree. If you start back over, you're not going to get the second degree polynomial. You can get the right answer as long as they're real answers. But when we get to the ones that are imaginary, you're going to want to get that thing to second degree so you can stop with the synthetic division. So it's important that you draw your house on that new line and start your synthetic division there. Okay? Next, let's try negative 1/2. I want you to remember you got the positives and the negative in this list. So let's try negative. So we know a negative and a positive is going to result in a negative. And I'm going to divide by 2, or you can say half of 6. It's pretty simple. Half of 6 is 3. So that's 13 minus 3, which will give us 10. Again, a negative and a positive will make a negative. Half of 10 is 5. 1 minus 5 is negative 4. 2 negatives will make a positive. And half of 4 is 2. And negative 2 plus 2 is 0. And as you see there, it zeroes out. So negative 1/2 is also a 0, which means an answer. So you found 2. Now keep in mind, this row represented x to the 4th. This row represented x to the 3rd. And now you're at x squared. So that's what I mean by getting it to that second degree row. I'm going to start with the synthetic division. So this will give us the polynomial of 6x squared plus 10x minus 4 equals 0. And here, I'm going to take out a GCF of 2. That will leave us with 3x squared plus 5x minus 2 equals 0. And we're going to factor. We are subtracting to get 5. So we have 3x and x is what I'm going to use in the front. And that's all I have in the front. And in the back, all I have is 2 and 1. And we're going to do 2 and 1. Because if you check that, outer inner, that would give us 6x and 1x. And I know if I subtract, that's a 5. Now make sure your signs are right. 5x in that polynomial is positive. So you must have a positive 6 and a negative 1. So my 1 has to be negative. My 2 is going to be positive because 2 times 3 is how I made 6. So if you set those parentheses to 0, you will see that x equals positive 1/3 and x equals negative 2. Those are my other 2 answers. So our four answers for this polynomial would be negative 2, negative 1/2, positive 1/3, and positive 1. Those are the four numbers that will zero this polynomial out.